this is pretty much the reading for today. You are going to read this and then take the quiz on its learning in the learning path. Sum of factors. This is an image of the strong winds and torrential rains between September 20th and September 25th, 1998, as Hurricane Georges trashed the Caribbean, leaving thousands of people homeless. The flutter of a butterfly's wings in Brazil can unleash a tornado in Florida. That was the conclusion arrived at in 1972 by Edward Lorenz after dedicating himself to the study of meteorology and trying to find a way of predicting meteorological phenomena that might put the lives of people at risk. In effect, the atmosphere is a system so complicated that many scientists define it as chaotic. Any forecast can rapidly deteriorate because of the wind and the appearance of a warm front or an unexpected storm. Thus, the difference continues to grow geometrically, and the reality of the next day is not the one that was expected, but entirely different. When there should have been sunshine, there's the rain. People who plan to go to the beach find that they have to shut themselves up in the basement until the hurricane passes. All this uncertainty causes many people who live in areas that are besieged by hurricanes or tropical storms to live in fear of what might happen, because they feel very vulnerable to changes in weather. It is also true that natural phenomena, such as tornadoes, hurricanes, and cyclones, do not in themselves cause catastrophes. For example, a hurricane becomes a disaster and causes considerable damage, deaths, and economic losses only because it strikes a populated area or travels over farmland. Yet in society, the idea persists that natural phenomena equate to death and destruction. In fact, experience shows that we have to learn to live with these phenomena and plan ahead for what might happen when they occur. In this book, along with spectacular images, you will find useful information about the factors that determine weather and climate, and you will be able to understand why long-term forecasts are so complicated. What changes are expected if global warming continues to increase? Could the polar ice caps melt and raise sea levels? All this and much more are found in the pages of this book. We intend to arouse your curiosity about weather and climate forces that affect everyone. Climatology. In this image of the Earth, one clearly sees the movement of water and air, which causes, amongst other things, temperature variation. The constantly moving atmosphere, the oceans, the continents, and the great masses of ice are the principal components of the environment. All of these constitute what is called the climatic system. They permanently interact with one another and transport water, as liquid or vapor, electromagnetic radiation, and heat. Within this complex system, one of the fundamental variables is temperature, which experiences the most change and is the most noticeable. The wind is important because it carries heat and moisture into the atmosphere. Water, with all of its processes, evaporation, condensation, convection, also plays a fundamental role in Earth's climatic system. Meteorology. This is an image of Hurricane Rita, in September 2003. The image from GOES-12, it looks like, the satellite GOES-12, shows the configuration of Hurricane Rita in the eastern portion of the Gulf of Mexico. The use of satellites orbiting the Earth, recording the comings of rain, air currents, and clouds, shows us how to know with some hours of advance warning if a severe storm is headed toward a certain point on the planet. Counting on this type of precise information about when and where tropical cyclones will occur, for example, has allowed government officials to coordinate the evacuation of people from the affected zones. The surface of the planet is also monitored by a system of meteorological stations placed hundreds of miles from each other. These collect information from and send information to all areas of the world so that meteorologists can prepare maps, graphics, and predictions to inform the public. Weather folklore. Before the development of meteorology as we know it today, people observed in nature signs that allowed them to predict rains, floods, or strong winds. All of this knowledge has been transmitted over the centuries in the form of proverbs or rhymes. Most of these fragments of meteorological knowledge lack a scientific foundation, but some of them reflect certain principles. Plants and animals play a major role in these observations. Signs from plants and animals. In every rural community, concern for the harvest and dependency on weather resulted in a series of beliefs, with varying degrees of accuracy, taken as prophecies of later events. In any case, even though it is certain that people as well as plants and animals react to the current weather, there is nothing to indicate that this might reveal anything about the weather in the future except to the degree that an incipient change is related to the current weather. For example, some signs accompany the increase in humidity that occurs prior to the passage of a cold front. So for example, when swallows fly low, get your rain gear in tow. So they're saying that swallows usually appear before a heavy rain. Open and closed pine cones. They say open pine cones mean dry weather, whereas closed pine cones mean humid weather. Donkeys. I hear donkeys braying. I am sure it will rain today. The animals react to the existing weather. It's a sign associated with the increased humidity of the environment. Dry seaweed. The lower the humidity, the more probable it is that the next day will be dry. A toad. When you see a toad walking, it will be a wet spring. When a toad is swimming in the water, this means it will soon rain. If it stays in the water without moving, the rain will last for some time. That's what they're thinking it means. Oak. If the leaves of oak fall before those of the ash, the summer will be dry. Versus ash. If the leaves of ash fall before those of the oak, the summer will be wet. Let's see. When the moon has a halo, tomorrow will have wet or bad weather. Halos occur as a consequence of the refraction of light by ice crystals in the cirrostratus clouds covering the sun or the moon. They portend a warm front, which will be followed by rain. Almanac forecasts. In the 16th century, almanacs with weather forecasts were sold throughout Europe. Each month of the year has its own refrain, although this depends on the hemisphere a person lives in. The monthly and annual calendars offered agricultural and medical advice. From the most remote times, there was a general belief that the moon determined the behavior of the atmosphere and that variations in the weather were caused by changes in the phase of the moon. Some examples of these popular sayings are, sweet April showers, dew spring May flowers. After a dark winter's night, the next day will be bright. Clouds. Clouds with a fringe of lining, secure your sails well. So this essentially means that clouds that are carried by winds at high altitudes are a sign of low pressure system. So like a cyclone might be coming. Weather predictions, there are thousands that relate to the changes in weather. So for example, wind from the east, rain like a beast. Morning dew and cool in May, bring wine to the vine and hay to the cow. I don't know what that means. Clear sunset, rainbow at sundown, good weather at dawn. Snails, when you see a black slug in your way, rain is not too far away. So snails are usually hidden in the garden. You only see them on humid days prior to rain. And now this is just an example of how information is compiled. So most of the information available regarding climatic data comes from the record that meteorologists everywhere in the world keep regarding cloud cover, temperature, the force and direction of the wind, air pressure, visibility, and precipitation. Then, from the meteorological station, the data is sent by radio or satellite, and this makes it possible to make forecasts and maps. So a barometer measures atmospheric pressure, so pressure in the air. And pressure in the air is the result of wind, right? So how fast are these molecules moving, as well as water vapor. How much water is there pushing down? How much vapor is there in the air, pushing and adding pressure? There's Android barometers. There are mercury barometers. All barometers measure pressure, but they use different things. So this one uses mercury inside of a glass tube, and based on the air pressure, the amount of mercury goes up and down. This one is an aneroid barometer, and it measures atmospheric pressure. This is a weather vane. So it's a perfectly balanced system, and it indicates the direction of the wind. What else? There are anemometers, which measure the speed of this wind. You have a bunch of different types of thermometers that measure temperature. A meteorological shelter would be made of something that insulates all of the instruments from the soil and protects them from solar radiation, so sun, so that way they're not affected. Weather stations are places where instruments are at ground level and can be used to measure this different data at different heights. What else is there? Impressions are when they measure the sunlight, so the electromagnetic radiation, rain meters, rain gauges. They measure how much precipitation there was. Instantaneous maps. Weather maps represent at any given moment the state of the atmosphere at different altitudes. These maps are based on the information provided by meteorological stations and are useful for specialists. The data collected by them include various values for pressure and temperature that make it possible to forecast the probability of precipitation, whether the weather will remain stable or if it will change because a weather front is moving in. So we are going to learn how to make some of these maps, but essentially I want you guys to take a quick look at some of these symbols. Isobar maps take a look at pressure in systems. It looks at atmospheric pressure, and it looks at where those pressures exist. So when you have a point where different pressures are meeting each other, or like different temperatures of pressure are meeting somewhere, that is how we find a weather change. So wind is usually when two different types of atmospheric pressure interact, and that creates wind. So usually the arrows are drawn in, I believe they usually point out toward the areas of, I guess, lower pressure, or in this case, where the lowest pressure is on the center. So we'll look more at these in a bit, but for now, just keep that in mind. All right, rain, cold, or heat. Knowing ahead of time what the weather will be is sometimes a question of life or death. The damage resulting from a torrential rain or heavy snowfall can be avoided thanks to the forecasts of meteorologists. The forecasts they make are based on information gathered from many sources, including instruments on the ground, in the air, and at sea. Despite the use of sophisticated information systems, the weather can be forecast only for the next few hours or days. Nonetheless, it is very useful in helping to prevent major catastrophes. So on land, it says that they're more numerous than what's made higher. In the sea, like boats and things help to measure water temperature. Oof. And then in the air, data is collected using airplane satellites or surrounding probes. And these are just a couple more examples if you want to look through them. Mobile satellites. Meteorological satellites, which have been orbiting the Earth for more than 30 years, are an indispensable aid to scientists. Along with the images generated by these instruments, meteorologists receive data that can be used to prepare weather bulletins. These reports, circulated via the mass media, allow people all over the world to know the weather forecast. Moreover, the most advanced satellites are used to study the characteristics of phenomena such as tropical cyclones, hurricanes, cyclones, and typhoons. So these are just a couple examples of satellites and how they are used. Alrighty, so go ahead and think about what we talked about. Primarily, I want you guys to think through what are the different factors that play a role. How do scientists gather data, and how do they share that data? And that is what we're thinking about for today. Thank you, guys.